Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will see a special case wherein there is a primary and standby database, and the requirement is we have to configure the Oracle GoldenGate replication to the target database. But the customer requirement is we don't have to touch primary database because it is overloaded, and in case you wanted to use, you can use the standby database. But the restriction over the standby database is it is always opened in read-only mode with apply. So this is what you say is the current setup which I do have. And let me go through the setup which I have. The setup which I have is everything is on virtual machine. The IP address of source database is 192.168.1.51. You can see, and I'm already logged into Mova Xterm. 61 is my standby database, and 71. I have two databases configured. One is my downstream database, which is MindDB, and the target database. So 51 is hosting the primary database, 61 is hosting the standby database, 71 is hosting the downstream mining database, and 71 also hosts the target database. So this is going to be a very special kind of setup wherein the primary database has not to be touched. The standby database is open into read-only mode so that we cannot make much changes. So we are going to introduce something called as downstream. So what we are going to do is we are going to use the cascading redo log. So whatever the redos are generated by the primary, it shifts to the standby, and from the standby it is going to be shipped to a downstream database, and from there we are going to start the extract, and the replicate is also going to run on to the same server because the mining database and our target database, they are hosted on 71, that is 192.168.1.71. So overview, we have a source database. The version is 12.1. A database name is source. The active DataGuard stand for standby. The active DataGuard name is standby. The database which will be used for mining purpose, the downstream database, its name is MindDB, and the target database is named as target. So here is the setup. We have virtual machine 1, 2, and 3. On 1, we have Linux 1 installed. The IP address is 51, and here we have the source database, and the schema is source test user, and the table names are source test table underscore 1, 2, 3, and 4. The standby database is hosted on 61. The database name is standby. It is open into read-only mode. 71, we have two databases which are already installed, MindDB and the target. On MindDB, we are going to configure the replicate, the extract, which is going to have the cascading redo logs. So in this entire scenario, we are not going to touch the primary. We are going to use the redos, which will be pushed to the mining database. The Oracle GoldenGate is already installed onto the target environment, which is 71, and we have two directories installed, one for extract, another for replicate. And this is the setup. Oracle GoldenGate is installed only on .71, which is having the target and the mining database. It is 64-bit. Our user which will be used for logging in is Oracle. This is the directory for what you say is for my mining DB, and for target it is. Let me put for the target as well. For the target, it will be OGG_target. OGG_target. Let me put it over here. The port is different because it is not going to be the same. It will not allow me to do that. And the port is the port which is used is 7812. 7812, and that is used for my target database. The local trail is going to be stored in /CRS home/MindDB, And let me show you the setup which I already have. We will test the standby database configuration, the DataGuard, which is already existing. So I'm logging into, so this is my setup. I'm logged into MobiXterm. That is a good tool to use. This is my primary database. I'll just try DGMG I'll connect through the sys, and you might be knowing that this is a bug. You can put any password and it is going to accept that. And then you say the show configuration, and it will show you the current status of. So you can see my primary database name is physical standby database name is standby, and the configuration status is success. Let me show you a script which is on primary database. What it is going to do is it will just do the switch log, and I'm already logged into there are 3 more windows opened wherein you can see this is let me change the color, change settings, and I'll say the color as white color, use system color. Yes, you can see that. So I have switched on the logs, and it is going to capture it over here. And this is how we have just did the basic testing. Now from the primary database, I need to TNS ping the all the environments. So what I'm going to do is from the primary environment, let me just say the TNS ping, and I have pinged the source itself, then the standby, it is successful, then I'm pinging the MindDB, and then finally the target database. What I'm going to do is I'm going with the configuration onto the primary database so that the cascading of redo logs starts happening. So let me log into the primary database. I'm logged in, and what I'm going to say is alter system set log archive config, and apart from source and standby, I'm going to include MindDB. We are going to add supplemental log data. We are going to create the GoldenGate table space, and we are going to create a user for the GoldenGate. Then we are going to grant the admin privileges, and then we will just verify it. Let's do it onto the primary database. This is being done. This may take a minute or so. Once it is done, what we are going to do is we are going to set up what do you say, the test environment. When I say the test environment, I'm going to create a schema which is source test user, and I'm going to insert rows in the 4 tables which will be created: source test table underscore 1, 2, 3, and 4. The configuration setting for cascading redo onto the primary database is done. I just included log archive config. I have included one more in this configuration, and I'm going to execute the script that is going to create a source test user, and it is going to create 4 tables: source test table underscore 1, 2, 3, and 4. Now what I'm going to do is the TNS ping is already done onto the primary database. Once this step is successful, what we are going to do is we are going to do it for the standby environment. So I'm waiting for that this script. Okay, this is already done. Let's go on to the active DataGuard standby configuration. And onto the standby database. This is my standby database. I'm able to ping it. There's a prerequisite, and let me log into the database onto the standby environment. We'll log in and we will check the DB unique name. There are 4 windows open, so we need to make sure that we are logged into the correct environment. So again, it is alter system set log archive config and log archive -3. So from standby, the redos will be shipped to the uh, MindDB database, which is hosted on 1.71. I think it is not pasted properly. Yes, read only with apply mode. Then we will fire alter system log archive config. This is done. Once it is done, you do this as well. This is done. Let's verify it, show configuration, and this should show that everything is fine. Yes, dgconfig has been set. Log archive -3 is configured. Remote login password that should be exclusive. Now in the next step, and you can check the MindDB alert log as well, so that it should start showing you on. This is my Linux 2. It will start showing the heartbeat failed to connect to standby. So this is fine because we have not done configuration onto the standby environment. That is MiningDB. So what I'm going to do on the Linux 3, which is hosting the MiningDB database, we are going to execute. We are going to take a backup, and we have taken the backup. Now what we are going to do is we are going to SCP the password file of source database to MindDB, and there we will rename it to MindDB. So it's a very simple step that has to be executed onto the primary database. Yes, Oracle, and now it is shipped to standby MiningDB database, which is Linux 3, and we have already received it. So let me show you the current timing. So this is 13:11. This is the old one. Sorry, I need to check for the MiningDB database. Sorry, the Aura PW source DB. So this is my Aura PW source. So what we have to do is we just need to rename it. So all the steps are clubbed together, and you can see that Aura PW source has been copied as Aura PW MindDB. So this is done, and now still you will see that error coming up into the alert log of Linux 2. Let's go to Linux 3. We'll do the TNS ping from Linux 3. This is my Linux 3. I can ping all the required databases. I'm going to make the directories which are required during the execution of some of the scripts. Let's cd and source the environment variables for MindDB database. env grab. So you need to make sure that you are logged into MindDB database. Yes. Let's log into the database. SQL plus sysdba. Just select the name of the database. It is MindDB. That's correct. And now I just wanted to cross check if archiving has been already enabled. It is already enabled, and I have to fire these commands. I have to configure log archive config, log archive dest1, dest2, and then I have to add the standby log files. So just executing all these steps. So this entire step is to we are doing it for cascading redo logs. So sometimes it fails. So this is log. This is for Linux 3. This is getting executed. Okay, this is done. Let me restart it as well. Sometimes it doesn't pick up properly, and we can check the alert log as well, because this should not return this error: heartbeat failed to connect to standby MindDB. I'm on to the Linux 2 because the cascading redos has to be shipped from Linux 2 to Linux 3, from my actual physical standby to new to be standby. I'm just receiving the redo logs from Linux 2 to Linux 3. Once this step is done, we will just check if everything is fine or not. Then we will do some switch logs onto the primary database. This will ensure that the archives are redo logs are shipped from primary to the new standby, which is I should not say it new standby, but the configuration should go there so that any switches I do on primary should go to standby and to Linux 3 as well. It is starting up. Yes, RFS network complete. So you can see that attempting destination network reconnect. So this is fine. So this is one of the very important steps, because if it doesn't work, the rest of the steps are not going to work. So what I'm going to do is I'm just going to switch some logs. So there is a basic shell script which says auto system switch log file, and I should be able to see everything in alert log of, yes, you can see assigned to RFS process. Yes, trying to get, yeah. So I believe this is working fine. I can fire one more switch and it should be visible over here. It is going to Linux 2 and the changes are happening to the Linux 3 as well. So far, whatever we have done, it is just see the redo logs are coming to the Linux 3 as well. So our first step is very successful. Now let's go to the Linux 3 environment and create so the table space is already created. What we need to do is we just need to grant DBA to ggadmin, and we need to execute this privilege. So let me log into MiningDB database. I think I'm already into that environment variable. Let me cross verify. Yes, this step is already completed. Just I'll execute it once again. If it has the table space is already created, it will error out. So what we are going to do is we are going to create a mining database capture user on Linux 3. That is my MiningDB. So far, whatever we have done only on, so this you can see the table space already exists. So I have done it in advance. So it's good to ignore this. Now what we are going to do is everything we are going to perform on MiningDB database. So I'll log into the GGS CI prompt, and then I'll create a wallet and we will do some user ID alias creation, and we will prepare the table space at tran data. We'll check it, and once this step is done, we'll move on to the standby database for the very important step. So on MiningDB, I'll just say cd, and there is an environment variable file. It will log into me to this. Let's create wallet, and this stuff we have done so many times in the past, so there is no point in discussing it. This is done. Let's add the tran data for all the 4 tables which are involved in this entire replication process. Then we'll just do a query if tran data is enabled or not from GGSCI prompt. The same can be done from SQL Plus as well, from mining database, sorry, from source or the target source or the standby database. Now what we are going to do, we are going to create and start downstream extract process. We are going to log into the database using GGSI prompt on MiningDB database, which we have already created. I'm not going to use the alias. Do it. I should not have used it, created it. That's no problem at all. And we will log into the mining database. This step is very important because through the mining database only we are logging into the source database. So everything will be, so register the extract with the source database. This is the last time we will be doing it onto the uh, source database. So far we haven't touched the primary database. So that was the whole requirement of this demo. So let it be untouched and do everything from the uh, standby database and mining DB database. So what we are going to do is there is a command no fetch user ID and fetch user ID. So we are going to use a standby database, and there is a very good trick in this. A standby database is opened into read-only mode, so we have to make sure that when we do the instantiation, we should be able to uh, do it using making it into read write mode. So I'm able to log in. We are going to register and add the extract. So once this is done, we are not going to what do you say, apply start the extract just for testing only. We have to apply a patch, otherwise it is going to error out, and the error will be patch 17030 189 is required for your Oracle mining database for trail format 12.2 or later. So our Oracle GoldenGate is 12.3. So we need to make sure that we apply this patch. Otherwise, it is not going to work. So the registering of the extract may take some time. In the meantime, what we will do is let's be ready with the patch, and everything is already copied. Info all extract is in stop status. Just say exit, shut down the database, SQL Plus as sysdba. We have to do it for mining database only. Shut immediate, and there is an alert log which I have already opened using you can see the putty. Once it is done, we will apply the patch. Patch is already copied onto the environment. It is copied and it is in unzipped status. It is in my home directory. So where is it waiting for now? Instance shutdown complete. So this should exit from the prompt. Yes, this is done. Let's say cd ls-lrt, and this is the patch which is in unzipped status. So this step is not required. I'll just export and say O patch apply. Nothing very special in patching it. Is just a very basic command. Once this is done, we will start the database and we will say data patch so that it is registered. Yes, SQL processes DBA, startup, exit from the prompt, and just say data patch. Come on. Yes, startup. And once it is done, we will just say data patch. Once this patch is applied, we will start the extract and we'll see if it is able to catch up. Although there is nothing in that, but it should be able to read it. database. Yes. So once this is done, what I'm going to do is I'm going to execute this step. Start extract ext1, and then I will look for mine. This should be available in my GGSCI alert log. So I'll just say ORINV underscore mining DB. I'll just say exit tail minus 100f GGS error log file. I have to view. Yes. And here, same command, cd uh, where is it? cd dot space orinv underscore minedb, and I'll just say info all. We'll try starting the extract just to make sure that it starts properly. Let's see. There is a warning that is fine, but it should come to the extract. And you have to look for this particular look for MindDB server DDL filtering enabled. So this should be visible. It takes a minute or so, and it should not die. Normally it dies, it abandons when this patch is not applied. But in our case, we have already enabled it, or we have already applied the patch before starting the extract. I'll just say info all. Although everything is being captured in those 4 minutes 47 seconds. Still, it has not moved further. It takes a minute or so, couple of minutes it will take. Once it is done and it is fine, then we will stop the extract and we will start it later. So you should be able to see this. And on the primary database, you have to make sure that you execute the log miner build proc. Sorry, this we have to execute this one. So we are able to see log mining server DDL filtering. In the meantime, just to save some time, log into the SQL Plus onto the source database and build this. This will again take 1 minute or so. This is highly suggested or highly recommended thing to be done onto the primary database. Log mining server DDL filtering enabled. This is fine. Under the primary database, I'm running this as well. This is completed on primary database. This is still going on. I'll just say info all. This should not bend, and normally it bends because of the patch not being applied. Again, in the meantime, what we will do is we will prepare the replicate parameter file onto the target database as well. So let this script go on, and it has still not completed. It should roll on to that particular extract file. Okay, let's go to the target environment. It is the mining DB database and the target database. They both are hosted on 192.168.1.71 only. So we will say .urinv_target. Well, still not completed. I believe, okay, this is still, let's wait for a couple more minutes. Okay, here I'll say info all, create sub-dirs. If it is not created, it already exists. So you can see there is a different directory now, which we have installed. Because it is a non-default location, just put the details into this is port 7812, and in .globals parameter we will put the details of the non-default trail file location. Let's create the wallet for target database. Okay, I can see, yes, output file is using format this is on my mining DB database where we have executed. Okay, let's say info all. Great, so you can see this is coming to time since checkpoint is 1 second. Now let's stop the extract. Under the target database we have created the alias, and let's create the replicate parameter file. Replicate rep1, and these are the tables. There are 4 tables, source test table _1, 2, 3, and 4. Now we are going to create the replicate parameter file onto target environment, and let me see if we have already created it. Added parameter rep1, and yes, I think we have already added it. And now what we have to do is we'll just register the replicates onto the target environments. Replicate is added. Now let's start the replicate, and we will see if it is rolled onto this particular file. So we'll check the OGG_target tail. What I'm going to do is we are going to view the alert log file of GGS target environment. Start replicate rep1, start mgr, and then start replicate. Replicate is running in integrated mode. So this should roll over to, and we should be able to see this wait for opened trail file and this one. And once we are able to see this message, and we should, if you say info all, it is 1 minute 15 seconds, so this should come closer to 0. Still it is not completed. Replicate rep1 started internally, it has gone for that, and we should be able to see this message, wait for open trail file. So this is the same thing We checked, okay, open trail file, this is fine. And now you should be able to see uh, time since checkpoint closer to 0 only. Yes, this is done. Now let's stop the replicate. And from here onwards, what we are going to do is we are going to instantiate the target database from standby database. We are not going to touch the primary database because the business requirement is you don't have to touch the production database because it is already overburdened, and we have to use the cascading redos which are generated onto the mining DB database, and that has to be further used. So if I let's go from here, start initial load from the standby database. So there is a script which says what is the current status of my database. So let me see the script. This is my standby database ls-lrt. I'm logged into MOVAX from 192.168.1.61, and we will say okay, I don't think I have that script copied. So let's log into the database. SQL Plus as sysdba. What we are going to do is we are going to stop the recovery, and we'll check the current SCN of the database. Just keep on checking it for a couple of times so that this current SCN is not changing further. So we'll note it down. So this particular current SCN will be used while we are starting our replicate. So that this is going to be very important. Now what we have to do is we have to cancel the recovery on a standby database. This we have already done. So this is a script which I was saying. This is canceling the recovery and checking the SCN of the database. Now in the next step, what we are going to do is we are going to convert the database into read-write mode, because in read-only mode we will not be able to use the expdb command. So what I'm going to do is it will convert the database to physical standby, then it is going to convert it to snapshot standby, and then it will open the database. So this everything will be done. So all these commands have put into a shell script, and we are going to execute it, and it's already available. So whatever is there on the screen, we are going to use that. Convert to read write standby.sh. It is canceling the recovery, which as we have already done. It is checking the current SCN. This is going to be important, and then it has converted into a snapshot database, and you can see the standby database into read write mode because we are going to do the instantiation from here only. Now we'll take an export backup. You can see the content. It is the four tables are involved. Source test table underscore one. Let me show you the script. It will be easier over there. And this script also does the SCP part, and it will SCP it to the mining database environment. So it is expdb ggadmin. This is the password, and this is the database, the standby database. It is going to take all the contents, and all the four tables are there. Source test table underscore 1, 2, 3, and 4. And then finally, once the export is done, expdp is done, it will do the SCP. It will put it onto the 71. Just execute it. Let's say sh expdp underscore standby dot sh. This is going to take at least 2 to 3 minutes. Once it is done, what we have to do is we will restore the status of the standby. In the meantime, what I'm going to do is I'm going to capture the current SCN, because we have to put it into this command when we are going to start the replicate, because replicate has to make sure that it starts the SCN after this so that there are no clashes. Expdp.sh standby. This is going to take the export backup of the four tables, source test table underscore 1, 2, 3, and 4, and then it will do SCP from primary standby database to target database. Just remember, the target database and the mining database both are hosted on our 71. So this is, if I say, okay, this step is already completed. This is my target environment, sorry, the standby database environment, and this is going on as usual. This is going to take at least 2 minutes, and once this is done, we should be able to SCP it. Everything is there in one script. Let me share the steps which we have to perform after this. After expdp.sh, we have to restore the status of the standby database. So what it will do, it will shut down the database, it will convert it to physical standby, then it will open into read-only mode, and finally we have to make sure that you should be able to see the same SCN which was available when you shut down the database. So where is it? Yes. This is still going on. Yes, and within a minute or so, it should be over. Once this is done, we will restore the status, then we will perform the import. So those both can be done simultaneously because there is no dependency of one on the other. So I'm waiting for this SCP to, yes, this is the, you can see there are four tables, source test table is equal 1, 2, 3, and 4. All of them are having closer to 50,000 rows. And this should prompt now for password so that SCP command is executed. This SCP command is done. Let's restore the data status of the database. So it is shutting down, converting to physical standby, and finally it is going to open it. We are going to do it into the standby database. And onto the target environment, I can fire an import as well. shimpdp2 target.sh. In case you wanted to see the alert, everything is here only. This is Linux 2. This is alert log of Linux 3, and this is Linux 1. Let me fire the import onto the target environment. Let me show you the script, just the basic cat. We should be able to see that content all should be available. Let's do impdp to target.sh. And let's see the status. 192.51.71 read only with apply status should be available, and 192.51.71, so we are good. And once the import happens, we should be able to see all the tables with the same count, and after that we will start the extract and the replicate, and what we will do is we will do a testing, and that's all about this wonderful. I really like it because this is a very good demo wherein we are not touching the primary database. The standby, that is also touched for the initial instantiation only, and then everything is being done onto the uh, mining database where the redos are reaching, and we are reading those redos, and the changes are replicated to the target database. You can see all the tables are imported. Under the target environment, the schema name is different. Target test user, the table name remains same. You can make the changes according to your requirement. Once it is done, we have to start the extract. Import is about to finalize. So we are very close to the end of this demo, but there are very, very important steps. This should get over any time. Import is still in progress. Once it is done, we will start the extract. Oh, this is done. The import has uh, completed successfully. Just start the extract. So the prompt is already there. I'll just say info all. It should be info all. Yes, start the extract. Start extract ext1. Just say info all. And we will start the target replicate as well. So this is ORINB. Let's go target. I'll just say info all. Start the replicate after that particular CSN. So just remember, it is not SCN. That is what we have got from the database. This is, you have to make sure you write after CSN. Otherwise, your replicate will not start. Just let me check the status of, yes, the extract has started perfectly fine. Let's start the replicate now. Replicate is running in integrated mode, so this is going fine. Once it is done, we will perform the testing. You can check the alert log of target environment as well. So you can see this redos, it is reading. Just say info all. The replicate is almost near to resent. And here, info all and extract is near to 0, so this is running perfectly fine. Replicate, it is also near to 0. This is also running fine. Now let's check and let's do a testing first. Before that, let's count the number of rows onto the source environment and the target environment. This is my source environment. Just don't be confused because we are so many terminals. There are 3 environments involved. One is source database, standby database, and the other one is target database, wherein we have hosted the mining DB database as well. The script is there, so you can see source test table underscore 1, 2, 3, and 4. All of them are having 49,564. On to the target environment. Let me show it over here. You can see it is both are fine. Now let's do some insert onto the source database, and we should be able to see it in the GGS error log file of extract and the target. So what is opened over here is replicate is running, so this is for the target environment. Let me open it for the mining DB database as well. Yes, so this is fine. Let's start our testing onto the source environment. We'll do some insert, and we have to make sure that they are replicated. Yes, this should be captured by the extract. So you can see the GGS error log file of this has populated. You can see there are something happening. Similarly, you can see it for target environment also. I prefer to keep this thing open so that we can check it immediately, but that's not the correct way. The correct way is we have to make sure that we check the status. So what we have to say is stats extract ext1 and stats replicate rep1. So that should be captured by the extract and later on by the replicate. So let's go to the ggsi prompt of this is my extract prompt. So I'll just save. You can see 1000 rows that have been inserted. They are picked up by the extract. The same should be picked up by the replicate as well. So what I'm going to say is ORINV was for target and for all. Here is my replicate, and I'll just say stats replicate rep1. You can see there are 1000 rows it has picked up. The source test table underscore 4, 3, 2. This is 4. This is 3. This is 2. Again, we can let's check it using the script which we have. Total count source data such. So we have 50,564 onto the source environment. Let's check it onto the target environment. So 50,564. 50,564. So we have done the testing. So this is really one of the best demo in terms of GoldenGate, because this has a very good kind of what do you say, the testing which we have done. So we have a primary database, we have a standby database. The customer is not willing to burden the primary database because that is a mission critical database. And even uh, this is not going to take a lot of resources, but they wanted us not to touch the primary database. The standby, we can touch it, and we have touched the standby only for the instantiation, and we haven't done anything beyond that. We open the database into read write mode so that we can take and uh, export expdp backup with a particular SCN that is used to start the replicate. So the key points in all this demo is we have to make sure that cascading redos is implemented so that the redo which is coming to the standby, that from a standby it should go to the uh, mining DB database. So we have a downstream database involved here. So everything we are going to do onto the downstream database. The extract is running onto the downstream, and the replicate is running onto the target database. We haven't done anything onto the primary database. We haven't done anything onto the standby database apart from the instantiation, which was temporary, and we have reverted it to the read-only mode. Mining DB database, we have done a lot because through the mining DB only we have logged into the source database only once just to do some basic configuration. Then everything is being done on the mining DB database, and the target database as usual has been used. Just remember, we haven't used the data pump because we both are hosted on the same box, and there is I prefer not to use the extract pump in this case. So I hope this is going to help. Thanks, and thanks for watching.